Finding vintage transformers for lighting projects requires exploring several specialized avenues. Firstly, consider online marketplaces such as eBay, Etsy, and the vintage section of Amazon. These platforms often host individual sellers and antique dealers offering a range of vintage electrical components, including transformers. Secondly, seek out vintage lighting stores. These establishments specialize in antique and vintage lighting fixtures and may have old transformers in their inventory. Contacting them directly or visiting their physical locations can be a fruitful approach. Thirdly, architectural salvage yards are another potential source. Salvage yards frequently carry a variety of salvaged building materials, including vintage electrical components that were removed from older buildings during renovations or demolitions. Fourthly, online lighting forums can be valuable resources. Join forums dedicated to vintage lighting, where members often share knowledge and leads on where to find specific vintage components, including transformers. Members may have personal connections, recommendations, or even surplus transformers they are willing to sell. Fifthly, antique electrical dealers specialize in antique electrical equipment. These dealers may possess old transformers or have connections to locate them through their networks. To ensure compatibility when selecting a replacement transformer, firstly, carefully determine the voltage and wattage requirements of the lights that the customer is using. Measure the voltage and wattage of the existing lights to ensure the replacement transformer can handle the load. Secondly, check the transformer specifications thoroughly. Look for transformers with voltage and wattage ratings that precisely match the requirements of the lights. Avoid selecting a transformer with insufficient capacity, as it could lead to overheating or failure. Thirdly, consider the physical size and mounting requirements of the transformer. Make sure the replacement transformer is compatible with the size constraints and mounting options of the existing lighting fixture. If space is limited, consider compact transformer designs. Finally, if there's uncertainty about any aspect of replacing the transformer, it's best to consult with a qualified electrician. An electrician can assess the situation, ensure safety, and guarantee proper functionality of the lighting system after the transformer replacement. The electrician can properly determine the appropriate transformer. If you encounter a transformer with unknown voltage, wattage, or amperage ratings, proceed with caution. There are steps you can take to estimate them. Firstly, visually inspect the transformer for any markings or labels. Often, transformers have nameplates or stickers indicating their voltage, amperage, and wattage ratings. Look closely for any faded or obscured markings. Secondly, measure the physical size of the transformer. Generally, larger transformers have higher power ratings. Compare the size of the unknown transformer to known transformers with similar physical dimensions to estimate its power capacity. Thirdly, determine the core material. The core material of a transformer affects its efficiency and power handling capabilities. Common core materials include laminated steel, silicon steel, and ferrite. Laminated steel cores are typically used in larger, higher power transformers. Fourthly, count the number of turns in the primary and secondary windings. The turns ratio is directly related to the voltage ratio of the transformer. If you can safely access and count the number of turns in each winding, you can estimate the voltage ratio. Fifthly, apply a low voltage alternating current signal to the primary winding and measure the voltage on the secondary winding. Use a signal generator and a multimeter to perform this test safely. The voltage ratio will give you an indication of the transformer's voltage transformation capabilities. Sixthly, measure the winding resistance. Use an ohmmeter to measure the resistance of the primary and secondary windings. The winding resistance is related to the wire gauge and the number of turns. Lower resistance generally indicates a higher current carrying capacity. Seventhly, estimate the apparent power using the transformer's physical characteristics and core material. Use empirical formulas or online calculators to estimate the apparent power in voltamps based on the transformer's size, core material, and operating frequency. Eighthly, if possible, consult with an experienced electrician or transformer specialist. They may have specialized equipment or knowledge to help you identify the transformer's ratings more accurately. Consider the application. Understanding the intended application of the transformer can provide clues about its voltage and current requirements. For example, a transformer used in a low-voltage lighting system will likely have different ratings than a transformer used in a high-power amplifier. Check the safety standards. Ensure that any testing or estimation methods used comply with safety standards and regulations. Use appropriate personal protective equipment, such as safety glasses and insulated gloves. When connecting a transformer, firstly verify the voltage compatibility. Confirm that the input voltage of the transformer matches the voltage of the power source. Connecting a transformer to an incorrect voltage can cause damage or create a safety hazard. Secondly, identify the primary and secondary windings. Determine which windings are the primary windings intended to be connected to the power source and which are the secondary windings intended to provide the output voltage. Typically, the primary and secondary windings are labeled or color-coded. Thirdly, ensure proper grounding. Connect the grounding wire from the power source to the grounding terminal on the transformer. Grounding provides a path for fault current, which helps protect against electric shock. Fourthly, use appropriate wiring and connectors. Use wiring and connectors that are rated for the voltage and current of the transformer. Ensure that all connections are secure and properly insulated. Fifthly, provide overcurrent protection. Install a fuse or circuit breaker in the primary circuit to protect the transformer from overcurrent conditions. Choose a fuse or circuit breaker with a rating that is appropriate for the transformer's current capacity. Sixthly, consider the load requirements. Ensure that the load connected to the secondary winding does not exceed the transformer's rated capacity. Overloading a transformer can cause it to overheat and fail. Seventhly, perform a visual inspection. Before energizing the transformer, perform a visual inspection to ensure that all connections are secure and there are no signs of damage or loose components. Eighthly, test the output voltage. Use a multimeter to measure the output voltage of the transformer. Verify that the output voltage is within the expected range. Ninthly, monitor the transformer's temperature. After energizing the transformer, monitor its temperature to ensure that it is not overheating. If the transformer becomes excessively hot, de-energize it and investigate the cause. Tenthly, follow local electrical codes and regulations. Ensure that all wiring and connections comply with local electrical codes and regulations. Consult with a qualified electrician if you have any questions or concerns. In addition to the above steps, consider the ambient temperature. Transformers are typically rated for operation at a specific ambient temperature. Ensure that the transformer is installed in an environment where the ambient temperature does not exceed its rated temperature. Also, provide adequate ventilation. Transformers generate heat during operation. Ensure that the transformer is installed in a location with adequate ventilation to allow heat to dissipate. Avoid enclosing the transformer in a confined space where heat can build up. Consider using a transformer with a higher temperature rating if the ambient temperature is high or if ventilation is limited. Consider the insulation class. Transformers are classified according to their insulation class, which indicates the maximum temperature that the insulation can withstand. Choose a transformer with an insulation class that is appropriate for the operating temperature. Consider the frequency. Transformers are designed to operate at a specific frequency, typically 50 Hz or 60 Hz. Ensure that the transformer is compatible with the frequency of the power source. Using a transformer at the wrong frequency can cause it to overheat and fail. Consider the inrush current. Transformers draw a high inrush current when they are first energized. This inrush current can trip circuit breakers or damage other electrical components. Consider using a soft start circuit or a transformer with a lower inrush current to mitigate this issue. Consider the harmonic distortion. Nonlinear loads can generate harmonic distortion in the electrical system. This harmonic distortion can cause transformers to overheat and fail. Consider using a transformer that is designed to withstand harmonic distortion or installing harmonic filters to mitigate this issue. Consider the altitude. The altitude at which a transformer is operated can affect its performance. At higher altitudes, the air is thinner, which reduces the transformer's cooling capacity. Consider using a transformer that is derated for operation at higher altitudes. Consider the corrosive environments. If the transformer is installed in a corrosive environment, such as near the ocean or in an industrial area, consider using a transformer with a corrosion-resistant enclosure or coating. Consider the noise level. Transformers can generate noise during operation. Consider using a transformer with a lower noise level if noise is a concern. Consider the efficiency. Transformers are not 100% efficient. Some energy is lost as heat. Consider using a transformer with a higher efficiency to reduce energy consumption and heat generation. Consider the total cost of ownership. The total cost of ownership of a transformer includes the initial purchase price, the cost of installation, the cost of energy consumption, and the cost of maintenance. Consider all of these factors when selecting a transformer. If you are replacing a transformer, it is important to properly dispose of the old transformer. Transformers may contain hazardous materials such as polychlorinated biphenyls, which can be harmful to the environment. Contact your local waste disposal agency for information on how to properly dispose of transformers.